Welcome to the Spring Boot and Microservices 2026 Mastery Guide. In this video, we'll walk you through everything you need to know to ace your interviews and stand out as a backend developer, microservices engineer, or system architect. We'll cover key concepts, practical scenarios, and real interview questions so you can answer confidently and design robust systems. Whether you're new to Spring Boot or looking to deepen your expertise, this guide is your one-stop resource for mastering microservices architecture and related technologies. Let's begin by understanding what Spring Boot is and why it's so popular in modern software development. Spring Boot simplifies the development of production-ready applications by providing a set of conventions and tools. It eliminates much of the boilerplate code, making it easier to create standalone scalable services. Developers love Spring Boot for its rapid setup, embedded servers, and seamless integration with other Spring ecosystem projects. In interviews, you'll often be asked about its advantages, so remember to highlight its ease of use, flexibility, and strong community support. Let's explore how Spring Boot fits into the broader context of microservices. Microservices architecture is a design approach where applications are built as a collection of small, independent services. Each service is responsible for specific business capability and communicates with others through APIs. This architecture enables teams to develop, deploy, and scale services independently, improving agility and resilience. In interviews, expect questions about the benefits and challenges of microservices, such as scalability, fault isolation, and complexity. Understanding these fundamentals is crucial for both technical and design interviews. Service discovery is a core concept in microservices. It allows services to find and communicate with each other dynamically without hard-coded endpoints. Tools like Eureka or Consul are commonly used for service registration and discovery in Spring Boot environments. Interviewers may ask how you implement service discovery, so be ready to discuss its role in enabling scalability and flexibility. Service discovery ensures that services can adapt to changes in the network, such as scaling up or down, without manual intervention. Centralized configuration is essential for managing settings across multiple microservices. Spring Cloud Config Server provides a way to store and serve configuration properties from a central location. This approach simplifies updates and ensures consistency, especially in large-scale environments. Interview questions may focus on how centralized configuration helps with version control, rollback, and environment-specific settings. Understanding this concept is key to designing maintainable and scalable microservices systems. Circuit breaker pattern is used to prevent cascading failures in microservices. When a service fails repeatedly, the circuit breaker trips and stops further requests, allowing the system to recover. Resilience 4J is a popular library for implementing this pattern in Spring Boot applications. Interviewers may ask about scenarios where circuit breakers are useful, such as handling timeouts or preventing overload. Demonstrating your knowledge of fault tolerance mechanisms will set you apart in technical interviews. Retries are a common strategy for handling transient failures in microservices. By automatically retrying failed requests, services can recover from temporary issues without manual intervention. Spring Boot provides built-in support for retries, often combined with circuit breakers for robust fault tolerance. Interview questions may cover how to configure retries, set limits, and avoid infinite loops. Understanding these patterns is crucial for designing resilient systems that maintain high availability. Communication between microservices can be synchronous or asynchronous. REST APIs are commonly used for synchronous calls, while messaging systems like Kafka enable asynchronous communication. Interviewers may ask about the pros and cons of each approach, such as latency, reliability, and scalability. Understanding how to facilitate communication in Spring Boot microservices is essential for both design and implementation questions. Let's dive deeper into messaging solutions next. Kafka is a distributed messaging platform that enables reliable, scalable, and asynchronous communication between microservices. It's widely used for event-driven architectures where services publish and subscribe to events. In interviews, you may be asked about Kafka's advantages, such as high throughput, durability, and fault tolerance. Demonstrating your understanding of Kafka integration in Spring Boot will show your readiness for real-world microservices challenges. Kubernetes is the de facto standard for container orchestration in microservices environments. It automates deployment, scaling, and management of containerized applications. Interviewers may ask about Kubernetes concepts like pods, services, and deployments, as well as how Spring Boot applications are packaged and deployed using Docker and Kubernetes. Understanding these tools is vital for modern backend roles, especially in cloud-native architecture. Monitoring is crucial for maintaining healthy microservices. The Elk Stack, Elasticsearch, Logstash, and Kibana provides powerful tools for log aggregation, search, and visualization. Kibana dashboards help teams track system health, identify issues, and optimize performance. Interview questions may focus on how you set up monitoring, handle alerts, and use logs for troubleshooting. Mastering Elk Stack integration with Spring Boot will make you a valuable asset in any team. Designing microservices involves careful planning of boundaries, responsibilities, and communication. Interviewers may ask about best practices, such as defining clear APIs, minimizing dependencies, and ensuring each service is independently deployable. You'll need to demonstrate your ability to design scalable, maintainable systems that meet business requirements. Let's discuss some common design patterns and their applications in Spring Boot microservices. API Gateway Pattern centralizes requests from clients, routing them to appropriate microservices. It provides features like authentication, rate limiting, and request aggregation. Spring Cloud Gateway is a popular choice for implementing this pattern. Interviewers may ask about its benefits, such as simplifying client interactions and improving security. Understanding API gateway design is essential for building robust microservices architectures. Security is a critical aspect of microservices design. You'll need to protect APIs, manage authentication and authorization, and secure inter-service communication. Spring Security provides tools for implementing these features, including OAuth 2 and JWT. Interview questions may focus on securing endpoints, handling user roles, and preventing vulnerabilities. Demonstrating your knowledge of security best practices will show your readiness for production environments. Testing is essential for ensuring microservices work as expected. You'll need to write unit tests, integration tests, and end-to-end tests. Spring Boot provides tools like JUnit and Mockito for testing individual components, while tools like test containers enable integration testing with real databases. Interviewers may ask about your testing strategies and how you ensure reliability. Mastering testing techniques will help you deliver robust, error-free systems. Continuous integration, CI, and continuous deployment, CD, automate the process of building, testing, and deploying microservices. Tools like Jenkins, GitHub Actions, and GitLab CI/CD are commonly used in Spring Boot projects. Interviewers may ask about your experience with CI/CD pipelines, automated testing, and deployment strategies. Understanding these practices is crucial for delivering software quickly and reliably. Scaling microservices involves increasing capacity to handle more requests. Kubernetes and Docker make it easy to scale services horizontally by adding more instances. Interviewers may ask about scaling strategies, load balancing, and handling spikes in traffic. Demonstrating your knowledge of scaling techniques will show your ability to design systems that grow with business needs. Choosing the right database is crucial for microservices. You may use relational databases like MySQL or PostgreSQL, or NoSQL databases like MongoDB. Interviewers may ask about database selection, data consistency, and handling distributed transactions. Understanding the trade-offs between different database types will help you design efficient, reliable systems. Distributed transactions are challenging in microservices due to the need for consistency across multiple services. Patterns like Saga and two-phase commit help manage these complexities. Interviewers may ask about transaction management, rollback strategies, and eventual consistency. Demonstrating your understanding of distributed transactions will show your ability to handle complex business scenarios. Event-driven architecture enables microservices to react to changes and communicate asynchronously. Kafka and are popular tools for implementing this pattern. Interviewers may ask about event sourcing, message brokers, and handling failures. Understanding event-driven design will help you build responsive, scalable systems. Handling failures gracefully is essential in microservices. You'll need to implement retries, circuit breakers, and fallback mechanisms. Interviewers may ask about your strategies for error handling, monitoring, and alerting. Demonstrating your ability to design resilient systems will show your readiness for production environments. Logging and tracing are vital for debugging and monitoring microservices. Tools like Elk Stack and Zipkin help track requests across services and identify bottlenecks. Interviewers may ask about log aggregation, distributed tracing, and troubleshooting strategies. Mastering these tools will help you maintain healthy, performant systems. Configuration management ensures that microservices have the correct settings for each environment. Spring Cloud Config Server centralizes configuration, making it easy to update and manage properties. Interviewers may ask about version control, rollback, and environment-specific settings. Understanding configuration management is key to maintaining consistency and reliability. API versioning allows you to evolve microservices without breaking existing clients. You can use URI versioning, header versioning, or content negotiation. Interviewers may ask about strategies for managing API changes and ensuring backward compatibility. Demonstrating your understanding of API versioning will show your ability to design flexible, maintainable systems. Rate limiting protects microservices from overload by restricting the number of requests a client can make. Tools like Spring Cloud Gateway provide built-in support for rate limiting. Interviewers may ask about implementation strategies, handling spikes, and ensuring fair usage. Understanding rate limiting is crucial for designing secure, scalable systems. Load balancing distributes requests across multiple instances of a microservice, improving performance and reliability. Tools like Ribbon and Kubernetes provide load balancing features. Interviewers may ask about strategies for balancing traffic, handling failures, and optimizing resource usage. Mastering load balancing techniques will help you design efficient, scalable systems. Health checks monitor the status of microservices and ensure they're running correctly. Spring Boot provides built-in endpoints for health checks, which can be integrated with Kubernetes and monitoring tools. Interviewers may ask about health check implementation, alerting, and automated recovery. Understanding health checks is key to maintaining high availability. Service registration enables microservices to announce their presence to a discovery server. Tools like Eureka automate this process, allowing services to join or leave the network dynamically. Interviewers may ask about registration strategies, handling failures, and ensuring consistency. Mastering service registration is essential for building flexible, scalable systems. Service deregistration removes microservices from the discovery server when they're no longer available. This prevents clients from sending requests to unavailable services. Interviewers may ask about deregistration strategies, handling failures, and ensuring consistency. Understanding service deregistration is key to maintaining reliable, resilient systems. Securing communication between microservices is essential for protecting sensitive data. You can use mutual TLS, API keys, or OAuth 2 for authentication and authorization. Interviewers may ask about security strategies, handling secrets, and preventing vulnerabilities. Demonstrating your knowledge of service-to-service security will show your readiness for production environments. Service Mesh provides advanced features for managing microservices communication, such as traffic routing, security, and observability. Istio is a popular service mesh for Kubernetes environments. Interviewers may ask about service mesh benefits, implementation, and integration with Spring Boot. Understanding service mesh concepts will help you design modern, cloud-native architectures. Observability enables teams to monitor, trace, and debug microservices effectively. Tools like ElkStack, Prometheus, and Grafana provide metrics, logs, and dashboards. Interviewers may ask about observability strategies, handling failures, and optimizing performance. Mastering observability tools will help you maintain healthy, performant systems. Resilience patterns help microservices recover from failures and maintain availability. Circuit breakers, retries, and bulkheads are common patterns used in Spring Boot applications. Interviewers may ask about resilience strategies, handling failures, and optimizing performance. Understanding resilience patterns is key to designing robust, reliable systems. Bulkhead pattern isolates failures in one part of a system, preventing them from affecting others. This improves resilience and availability. Interviewers may ask about bulkhead implementation, handling failures, and optimizing performance. Mastering bulkhead pattern design will help you build robust, scalable microservices. Rollback mechanisms provide alternative responses when a service fails. This ensures clients receive meaningful results even during outages. Interviewers may ask about fallback strategies, handling failures, and optimizing performance. Understanding fallback mechanisms is key to designing resilient, user-friendly systems. Distributed caching improves performance by storing frequently accessed data closer to the client. Tools like Redis and Hazelcast are commonly used in Spring Boot microservices. Interviewers may ask about caching strategies, handling consistency, and optimizing resource usage. Mastering distributed caching techniques will help you design efficient, scalable systems. Session management ensures that user sessions are handled correctly across microservices. You can use token-based authentication, distributed session stores, or stateless designs. Interviewers may ask about session management strategies, handling failures, and optimizing performance. Understanding session management is key to designing secure, scalable systems. Service versioning allows you to evolve microservices independently without breaking existing clients. You can use URI versioning, header versioning, or content negotiation. Interviewers may ask about strategies for managing service changes and ensuring backward compatibility. Demonstrating your understanding of service versioning will show your ability to design flexible, maintainable systems. Service monitoring tracks the health and performance of microservices. Tools like ElkStack, Prometheus, and Grafana provide metrics, logs, and dashboards. Interviewers may ask about monitoring strategies, handling failures, and optimizing performance. Mastering service monitoring tools will help you maintain healthy, performant systems. Service scaling increases capacity to handle more requests. Kubernetes and Docker make it easy to scale services horizontally by adding more instances. Interviewers may ask about scaling strategies, load balancing, and handling spikes in traffic. Demonstrating your knowledge of scaling techniques will show your ability to design systems that grow with business needs. Service testing ensures that microservices work as expected. You'll need to write unit tests, integration tests, and end-to-end tests. Spring Boot provides tools like JUnit and Mockito for testing individual components, while tools like test containers enable integration testing with real databases. Interviewers may ask about your testing strategies and how you ensure reliability. Mastering testing techniques will help you deliver robust, error-free systems. Service deployment automates the process of building, testing, and deploying microservices. Tools like Jenkins, GitHub Actions, and GitLab CI/CD are commonly used in Spring Boot projects. Interviewers may ask about your experience with deployment strategies, automated testing, and CI/CD pipelines. Understanding these practices is crucial for delivering software quickly and reliably. Service design patterns provide best practices for building scalable, maintainable microservices. Patterns like API Gateway, Circuit Breaker, and Bulkhead are commonly used in Spring Boot applications. Interviewers may ask about design patterns, handling failures, and optimizing performance. Understanding service design patterns is key to building robust, reliable systems. Throughout this guide, we've covered the essential concepts, patterns, and tools for mastering Spring Boot and microservices. From service discovery and centralized configuration to resilience, security, and monitoring, you now have the knowledge to answer interview questions confidently and design robust systems. Remember to highlight your practical experience, understanding of patterns, and ability to solve real-world challenges. Let's wrap up with a quick recap of the most important points. Congratulations on completing the Spring Boot and Microservices 2026 Mastery Guide. With this knowledge, you're ready to tackle any interview and build scalable, resilient systems. Keep practicing, stay updated with the latest trends, and continue learning. Your journey as a backend developer or microservices engineer is just beginning, and this guide will serve as your foundation for future success. Good luck.